Engineering Manager for Iceni Napola's Engineering Department. And welcome to our presentation on understanding unvented attic and use configuration approvals. We're glad you could join us today. The presentation for your information will be recorded so that you could revisit it at a later time or pass it on to somebody else in your organization. Since this is the first presentation that we've given to our customers, dealers, installers, we thought it might be a good idea to present ourselves in the engineering department and how we can help you. So you see here is the engineering team and our email addresses and phone numbers. There's myself, and we have two senior engineers, Randy Nicholas and Jay Saldana. And we are located in different parts of the country, but we can help you with any kind of issues, inquiries that you have, no matter where you are located in the country. There are certain ways that we can help you. In terms of product usage, whether you're using a Napola brand product or a Iceni brand product or an open cell or closed cell product, we can help guide you or your customers in using those products to the best way. We can provide all kinds of technical information. There is some information located on the website, and there are other pieces of information like test reports, and we can provide clarity, for instance, on certain passages in evaluation reports. We are very good at helping with code compliance issues, talking to code officials, and we have a full catalog of the IRC, the IBC, the ICC, as well as state codes, going back probably 15 years now. So we can refer to all that information to help you with any kind of code compliance issues you may come up with. In terms of material compatibility, we can help out with looking at how foam is compatible to certain materials, say piping or construction membranes, for instance. If you're doing commercial work, we can help out with your engineering evaluations that you might need for the architects or code officials. So they would contain information on how our spray foam products would perform in a fire-rated wall or in an NFPA 285 wall assembly, for example. All of us are building science resources for you to help yourself and any customer questions that may come up of a building science nature that needs to be addressed. Stuff like, is this assembly going to handle condensation appropriately? And lastly, we are able to do technical presentations all across the country on a variety of topics. And we've done those kinds of presentations for code officials, home builders, architects, and we can help you out if you need something like that done in your area. So with that, I'd like to pass the presentation on to Jay Saldana, who is our main presenter for today. Thank you for joining us.
Thank you, John. Real quick, before we move forward, I want to go over a little bit of the format. We're going to keep this a presentation only. Just for time purposes, no questions during the presentation. But I encourage you to type your questions into the chat box, and at the end there will be time, and we'll be able to read these questions and go back into the presentation if we need to look at different slides. So I appreciate you following that format, and that way we'll be able to keep the presentation moving in a timely manner. So don't forget to type your questions. With that, we'll get to the agenda. Again, my name is Jay Saldana. And just a little bit of background, I am a licensed PE, just like John and Randy. And, my experience prior to working for Iceland Lapola was with a rigid polyiso manufacturer. So I've got a unique look at the industry from both the rigid foam side and the spray foam side. Keeping that in mind, today we're talking about in-use configuration, and mainly the main subject that we're going to hit on here is myths and misconceptions and understanding exactly what in-use configuration testing is. But in order to really get to this bullet point and discuss it correctly, we need to first make sure we're all on the same page about what an attic is, where thermal barrier and ignition barriers are required in the code, what is Appendix X, and then what is in-use configuration. And once we understand and we're all on the same page with those topics, we can go into this and then quickly discuss what sort of third-party approvals we have and use to be able to get approval. So, what is an attic? The IRC defines an attic as the unfinished space between the ceiling assembly and the roof assembly. Interestingly, there is no definition in the IRC for ceiling. So it kind of leaves that up for interpretation. So we'll get to that point in just a second. But what we need to know for our purposes, an attic has structural members that the floor could be walked on, the floor that could be walked on. That's important to remember. Structural members on the floor that could be walked on. And it has a gypsum enclosure on the underside of those structural members. So we need the gypsum board on the underside. And all of that is, quote, the ceiling that is created between the roof and the ceiling. And that ceiling is what we would need to have in order for it to be considered an attic. And then to be even more clear, what is not an attic? So the space between the roof and the occupied space that's separated by a drop ceiling. So those drop ceiling, those lay-in tile panels, sometimes they are gypsum board, but it's not a structural member, right? We don't walk on those. So that does not create an attic for our purposes. In fact, we have yet to find any building official anywhere that would consider the space between a drop ceiling and the roof an attic. So that's important to remember that does not create an attic. Space between the roof and occupied space used to convey conditioned air, which essentially creates a plenum. Now, a lot of times the just talked about category of a drop ceiling will have a plenum above it, and a lot of people will refer to every drop ceiling as having a plenum above it. But what's important for us to know as a foam plastic insulation industry is that the plenum, an actual plenum that conveys air for the conditioning system, comes with different requirements. So the generic term thrown around plenum, most people just use that as a definition for space. But in reality, if it's not conveying air for the conditioning system, really what you have is called a concealed space. That is defined in the code. So for us, we need to make sure we know the difference. If someone's calling it a plenum, we need to ask the question, hey, is it conveying air for the conditioning system, or are you actually talking about a concealed space? There are different requirements for each of these. These are more generic. The plenums can get more complicated. So it's important that we understand the difference when we're talking about that. Here's a little tidbit of information for you. The term thermal barrier only appears in section 316, which is the foam plastic section of the IRC. So it's not elsewhere other than there's a definition of thermal barrier at the beginning of the code. And then there are a couple instances in the IRC where it refers to thermal barrier, but it's actually talking about insulation as a control layer. So the code will use the term thermal barrier, but it'll mean insulation layer. So thermal barrier is only referred to in the IRC as when we talk about the 15-minute thermal barrier in the foam plastic section. In the building code, it appears multiple times in the code, most of them references to the 15-minute thermal barrier. So it's just interesting that it doesn't appear as much in the IRC. So where are thermal barriers required? I have here two excerpts from the code, one for the residential code and one for the commercial code. And they're both very similarly worded, but there is a difference. Starting in the 2015 IRC, they have added a prescriptive 23/32. For those of you good at math, that's just about 3/4 inch. So 23/32 inch wood structural panel as a prescriptive 15-minute thermal barrier. So it's always been 1/2 inch gypsum board, minimum 1/2 inch gypsum board, but they've added 3/4 inch wood structural panel. So that's new. And starting in the I'm sorry, not 20. In the 2015 code, yes. And what's interesting is that they did not add that into the building code. The building code still only references 1/2 inch gypsum wallboard. And I will make the argument every day of the week to a building official that a fire does not know whether it's in a residential home or a commercial home. That when fire is happening, it doesn't know the difference. So if 3/4 inch wood structural panel is good enough to be a 15-minute thermal barrier in residential code, it should be good enough to be a 15-minute thermal barrier in the commercial code. But apparently, since it's not listed, it's up to interpretation. We can try to convince the building official. Should that need arrive, that's a service that our engineering team can help try to do, but there's no guarantees since it is not actually listed there. But it is important to note that it got added. But the real main takeaway from this slide should be that all foam plastic shall be separated from the interior of a building. So essentially, if you're using spray foam in a building, spray foam is a foam plastic, it should be separated from the interior of the building by a 15-minute thermal barrier. Now, there are exceptions, okay? One of those exceptions being attics and crawl spaces. The building code points out that it needs a 15-minute thermal barrier everywhere unless it's in an attic or a crawl space. And so in these locations, you only need a lesser quality ignition barrier. The ignition barrier is considered a lesser quality than the 15-minute thermal barrier. In both these commercial and residential sections, I'm sorry, not commercial and residential, but in both these attic and crawl space sections, they list prescriptive ignition barrier options. But in the attic section specifically, and in the crawl space section, it's just not highlighted here, it specifically calls out unless you have testing in accordance with chapter 316.6. 316.6. So the prescriptive ignition barrier is not required if you test according to 316.6. So let's go over it one more time. Everywhere foam plastic is used, you need a 15-minute thermal barrier. Unless it's in an attic or crawl space, then you only need an ignition barrier. Unless you do testing according to this section. So let's see what that section is. That is the specific approvals section. Specific approval. So foam plastic not meeting the requirements of the thermal barrier or ignition barrier sections can be allowed as long as you do testing listed here, right? And I have highlighted here, or fire tests related to actual end-use configurations. So they have specific tests and then call out or fire tests related to actual end-use configurations. So this is where the IRC code specifically allows for end-use configuration testing to get around thermal barrier and ignition barrier testing? Well, what are the other options? What are those tests? Are these ignition barrier tests? They're listed, right? They were just listed. These were just listed in the code section. NFPA 26, that's common. UL 1715 and NFPA 26 are kind of cousins of each other. These two are similar, but different scale testing, not used as often. But according to these test standards, these are all interior finish thermal barrier tests. So none of these tests run according to the standard would give you an ignition barrier result. They give you thermal barrier results. So then how do we go around to try to find an ignition barrier test? Well, that is exactly what Appendix X is. Appendix X was developed by ICC ES. They're a subsidiary of ICC. ES stands for Evaluation Service. These guys developed a acceptance criteria. AC stands for acceptance criteria 377. And in this criteria, they have a test method called Appendix X. And essentially what they do is they alter the NFPA 286 test to account for the lesser quality ignition barrier. And the word alter is subjective. Really what they do is they shorten the test. If the 286 test was 15 minutes long, the ignition barrier Appendix X version is less than 5 minutes long. It's actually 4 minutes and 18 seconds. So it's a shortened version of the test. It's not prescriptive in the code. It is created by ICC ES acceptance criteria. Appendix X is not referenced in the code. It's only given approval by the third-party services. Appendix X, so I got ahead of myself here, is a shortened, modified version of the 286. We have a couple images here, and hopefully they're showing up bright enough for you guys. But what they do is they're called an interior finish test because you build a room and you apply your product to the interior surface of that room, and then you burn it. In this corner right here is a it's a sandbox with a gas burner. This is the gas line here going to that sandbox, and it diffuses the gas through the sand evenly to create a square surface for the fire to come straight up. And that's placed 2 inches away from the walls. And then through the test standard, they control the amount of heat that comes out, the amount of BTUs that comes out of that fire, and it catches the room on fire, and your product will either survive or not survive. And for the ignition barrier portion, you cannot have ignition of your product at the top of the roof or the underside of the ceiling here. So if you turn this on and inside of that 4 minutes and 18 seconds, a fire starts here or climbs up the wall to this location, then you fail the test. So that's Appendix X, in that the fire is not, it's not that the foam is not catching fire, it's that it hasn't spread to the top. But as you can visually see here, this is nothing like an attic. There's a big, huge door here that's open. There's cameras that watch. This guy is, visually inspecting. Usually he'll have a water hose here ready to spray it down if the fire gets out of control. And this is an interior finish test. It is not anything like what an attic is. But that's what's been determined by ICC ES as an ignition barrier test rather than a thermal barrier test. So what is end-use configuration testing then? One of the things that we have done based on a lot of confusion in the industry is try to explain what end-use configuration testing is. And we've developed this trifold document that we find is very, very useful in helping people understand what the end-use configuration testing is, how it's different, and just as safe, and that there's nothing tricky about it. It's just different. That's all. And I've been told that the marketing department will include this document in follow-up emails so that everyone can have a chance to see it for themselves. But what we're going to do is go over these individual sections and walk through them so that when you are trying to explain to anybody how end-use configuration works and how it's different, that you'll be able to hear it from us, the engineering department, and kind of use that to point back to these different sections of this trifold. It's a great conversation starter. It's not intended to solve all your problems for you, but it's a great way to leave someone with information so that you don't walk away from the conversation with that person thinking that what you're doing is unsafe, because that is absolutely not the case at all. And to be clear, that the end-use configuration testing is for unvented attics only. So this is not for vented attics. The end-use configuration testing is for the unvented attic only. I'm sure we have that clear. Okay, so these are the different sections in this trifold. So let's start out with what's easy to know. What's the easy thing to know? End-use configuration testing is the prescriptive building code and tests what would happen in real-life situation if an unvented attic caught fire. That's important to understand, especially when you can explain to someone what Appendix X is, which is not a real-life attic scenario. It's a interior finish test. Testing demonstrated that icing Lapola spray foam in an unvented attic self-extinguishes in less than a minute. When ignition barriers are required, passing the rigorous end-use configuration testing for unvented attics allows spray foam to be installed without additional coatings. So just like the Appendix X test, the foam catches fire. But ours, we show that it puts itself out. It self-extinguishes. So whereas the Appendix X test at 4 minutes and 18 seconds, the fire may still be going. If it reaches the ceiling at 4 minutes and 19 seconds, you still pass because you didn't reach the ceiling at 4 minutes and 18 seconds. In our test, by 4 minutes, the fire would have been long out already. It would have put itself out. So that's a point that you want to make sure people understand. So what's hard? Well, end-use configuration testing isn't the easiest, fastest, or cheapest path, but a majority of the spray foam industry has found it includes real-world construction considerations that Appendix X does not account for. We're talking about a number of things that are accounted for in the end-use configuration test that aren't even a blip on the screen in the Appendix X test. Appendix, and I think one more thing it's important to find out, or important to say, that it's not a one test and you're done application. This requires multiple tests for every manufacturer in order to prove out several different scenarios that the fire will put itself out. So whereas Appendix X is one test, if you fail, you can do it again, and if you pass, well, then you're good. Whereas our test, you got to do multiple tests, and you have to pass them all. So it is not cheap, but it is certainly accounting for a lot of variables that helps make it safe. So why don't we compare the two here? Appendix X, again, each one of these slides that you're looking at is a section of this trifold. Appendix X it's non-prescriptive, modified NFPA 286 test, whereas end-use configuration is prescriptive end-use configuration test. So the end-use configuration test is prescriptive. we showed you that it's called out in the code that end-use configuration can be used. Appendix X is not called out in the code. It is only approved by the third-party verifications. End-use configuration is called out in the code. Appendix X is a room corner burn with a gas burner. It's essentially 8 foot by 12 foot by 8 foot. It's a square rectangular room. End-use configuration is an attic-shaped room, including pitch roofs of varying sizes with a gas burner in the corner. So they both rely on the gas burner as the source of the fire. But again, this is shaped like an attic. The end-use configuration is shaped like an attic. The Appendix X has a full-size door on the wall opposite of the burner, whereas end-use configuration is typical attic construction with entry only at the attic hatch in the floor. So it's the assembly, you can't even get into an end-use configuration unless you go under it and walk up through the attic doors. Appendix X, passing means 4 minutes and 18 seconds. The fire has not spread to the ceiling, but typically is still burning. End-use configuration, passing means that the fire extinguishes in less than a minute and stays extinguished. This is also important, stays extinguished. Not only does it put itself out, the test protocol requires watching the room for, I can't remember if it's 1 hour or 2 hours after the test to confirm that it doesn't reignite itself. So that's important. Whereas this one, as soon as 4 minutes and 18 seconds in, whether the fire is still going or not, it's a pass, as long as it doesn't reach the ceiling. So again, these are important bullet points to make sure that anyone who has a question about the safety understands. So we also include these diagrams to give you an example. The end-use configuration test is built just like an attic. We've got walls, got a pitched roof. There's no door in the front. It's somewhat difficult to draw this to see through, but there is an intended door here, right, that you walk in. We've got wood joists on the ground. You've got a pull-down ladder that goes in. So this is just like attic conditions, and this is just a room with a big opening into it. There is no actual door. It's just a hole cut out. And then just to be clear, this wall here where the opening is, there is no spray foam on this wall. So there's only spray foam on the side walls and back wall and the ceiling. Whereas in this room, there's spray foam everywhere, all 4 walls, the ceiling, exactly as it would be in an attic. And again, however you'd build an attic, that's how this room is built, with wood, exposed wood materials. So this diagram is on the trifold. There's a lot of information here, but this is very important also, this section. This is the misconceptions versus truth. So you as an installer of end-use configuration foam may have heard these before, and here is the truth about these misconceptions. It requires mysterious, and they're in quotes because we have heard these words before, or magical attic hatch. All right, and there is nothing confusing, mysterious, or magical about the hatch. It's simply an attic hatch that meets building code. It needs to open downward, and it can't latch. A common example is your typical pull-down stairs. The reason it can't latch is because the room is the attic is unvented. An unvented attic means air is not escaping out of it. And when you have a fire that heats up the air, it creates gases. Pressure builds up in that attic because the hot air wants to rise, but it can't go anywhere because it's unvented. If you had a locking hatch, then at some point the pressure would build and blow open it's not guaranteed. At some point, the pressure might build and blow open a part of the structure. The way to prevent this is to ensure that you've got your common pull down stairs, or as we're going to move here, talk about here, scuttle holes, and that will allow the pressure to, for lack of a better word, burp and release some of that pressure so that it doesn't damage the structure. And so, because we talk about the pull down attic hatch, the other misconception is you can't use scuttle holes. Well, that's not true. They are allowed. We've done testing with a product called Rockfon to show that when it's utilized in a scuttle hole, that if the pressure builds, it will force the Rockfon to bend downward and fall through the scuttle hole, which then allows the pressure relief. So it's important to note that the testing, one of the variants of testing, I didn't mention this. One of the variants of testing in the several tests that you have to do for in-use configuration is with the attic hatch completely open, so that you can show whether the hatch is closed or open, that you still pass the test, that it still puts out the fire. So the thought of the pressure building and opening that hatch through pressure is fine, because in order to get approval for in-use configuration, you've passed with the attic hatch completely open. It just needs to have the ability to release the pressure. Okay. Danger signage required. We've heard this before. There is no danger signage required to be left in the attic space. So this is absolutely not true. The Intertech CCRR reports require a notification that it is an unvented attic, but there is nothing about being dangerous. They just simply want a note to be left that it is an unvented attic, not that there's anything dangerous. They just want people to be aware of that. Partially because of this next one, that there can be no homeowner modifications. Well, that's not true. You can modify things as you need to, as long as the attic is still unvented when you're done. If you have to cut a hole in your roof to put a new, I don't know, I can't think of a reason to, maybe you had a crazy hailstorm and it busted through your wood sheathing, and you're gonna patch it up from the outside. Well, all you need to do is ensure that you've returned the attic to an unvented state. Then you're good to go. Okay, that's what's important to know. Builder and contractors are liable down the line. Well, that's absolutely not true. If they're going around saying that the builder or contractor is liable simply because they use an in-use configuration, that's not true. In-use configuration is third-party approved by ICCES, Intertech, and DRJ Engineering, based on over $1 million of industry testing when you count for all the manufacturers that do it. The whole point of these third-party approvals is to confirm that the application meets building code. Now, you as installers still have to, you're on the hook to install it correctly, which is true with all contractors. But there is nothing more dangerous, more libelous about the fact that you're using in-use configuration than other approvals, than other testing standards. It's been approved by third party. So if Icing the Pola has the approval, therefore you can move forward, and you're not any more liable than someone using Appendix X, as long as you install it correctly. Another rumor: attic floor and can lights require air sealing. This is actually not true, and is the opposite of what you want to do. You want communication with the interior space if you have an unvented attic. This is whether you use Appendix X or in-use configuration. an unvented attic needs to communicate with the occupied space. Again, it's approved by these third parties based, oh wait, I'm reading the wrong one. It's not required. The testing was performed with no air sealing of any elements on the attic floor. So all that testing that we did, whenever you add penetrations in your penetration test portion, we don't encourage or we don't seal any of those. There's no air sealing going on. And again, building science encourages that communication. It helps the unvented attic. So you don't want to seal those to the attic floor. So this is a big one that we've heard a lot about. A blowtorch shows in-use configuration foam catches fire. Well, I got news for everybody. All foam plastic insulation is combustible. All of it. When the flame source is removed from spray foam, the fire extinguishes. If you take a chunk of foam and you put a blowtorch to it, it doesn't mean it'll keep burning till the end of the world. You put a blowtorch to it. If it catches fire, remove the blowtorch, and eventually that fire is going to go out. It's like wood. If you take a log out of the fire, it stops burning. It needs that communication with the heat source to keep the fire going. So it's just silly. Anyone who is sitting down right now on a chair or a couch, you're sitting on some sort of foam. That foam is combustible. It's all combustible, right? So we taking a blowtorch to something is not a test of whether or not something is safe. That's not real world condition. And so the other thing that the competition likes to say often is it's oxygen depletion protocol. They do this on purpose because they don't want to say that it's end-use configuration testing. They don't want to say that because this is prescriptively allowed in the code. Okay? Oxygen depletion occurs during the test, but it is not oxygen depletion protocol. It is end-use configuration testing. That's important that we say that as many times as we can to get that in people's heads. Oxygen depletion occurs during the test, but it is end-use configuration testing, which is prescriptively allowed in the code. All right. Now, this is a little bit more detail about the attic hatch. And whoops, didn't mean to do that. A little bit more detail about the attic hatch here. So let's just make sure we're all aware. Again, unlike Appendix X, the end-use configuration testing goes beyond just considering the fire itself. This is kind of explaining why the downward hatch is necessary. I explained it earlier about the pressure that builds, but this is putting it in bullet points that someone can understand. End-use configuration testing accounts for the pressure and provides a way to release it if needed. Building code requires attic access, so it made practical sense to use the attic hatch as part of the pressure relief configuration. It is actually our opinion that all unvented attics should have this pressure relief mechanism, that even Appendix X attics should have it. If they are truly unvented and a fire occurs, pressure will build. It's important that they also have the relief mechanism. And again, it's nothing magical. Code compliant hatches that typically open downward with no latch. This will provide all you need right there. Code compliant, downward opening, no latch. We're good to go. Scuttle holes can be used based on the Rockfon Pacific 201 panel. We went over that. And again, even if the attic hatch is open or closed, the testing we have done shows that the fire will still go out. So this brings to the point that the only real importance is that the attic hatch is not latchable, that it can open downward and allow for that pressure relief. If you wanted to build a home with no attic hatch at all, and you just wanted to leave it an open hole in the ceiling, you could do that. I think code requires it to be closed, but you could technically do that and it would still pass our testing. The downward opening hatch is to provide the additional safety of pressure relief should it be needed. There's nothing magical about it. It's just logical. The pressure relief should be there whether you have Appendix X or end-use configuration. Feel free to make that point anytime you want. What's interesting is that until end-use configuration testing came around and Appendix X was all there was, no one knew this. They didn't understand this concept. So it was the end-use configuration testing that brought this to light of why it's important. And then in this document, we include a couple examples. So your typical downward opening hatch, stairs, it doesn't latch, spring-loaded type things, and a scuttle hole. This just needs to be a rock fawn panel, and if pressure builds, it'll bow in the middle and push itself downward through the hole. Nothing magical. And again, in this trifold, we very clearly point out where it calls out prescriptively end-use configuration testing. This is the same language that I showed you earlier. It's just typed out nice and neat with some highlighted colors. But this is where it calls out the fact that actual end-use configurations are prescriptive in the code, and they're mentioned both in the building code and the residential code. So it's there in both of them. So this is in the trifold. So let's briefly go over third-party approvals here. The original process of testing was developed with Priest and Associates, and they created the engineering evaluation report based on all the testing done. And this report is what was submitted to the third-party approval companies. There's IRC EBC, there's DRJ, and Intertech. All three have approved end-use configuration. So that brings a lot of validity to what it is that we're saying. We used a third-party fire consultant to perform and analyze the testing. We used a third-party lab to actually do the testing. And then we submit it to a third-party certification body that reviews the testing and confirms it meets code. So anyone who talks about end-use configuration isn't safe really needs to go back to these third-party companies, and if they think it's not safe, then why did these highly recognized companies approve it? So for third-party conditions must be met. So there's this is instead of the prescriptive ignition barrier. There are a couple qualifications that the third-party companies put onto the attic, and this is actually the same as Appendix X. So if you're going to use rely on IRC EBC, DRJ, and Intertech as your third-party approval document, they say if you're not going to use a prescriptive ignition barrier and you're going to do some form of testing instead, whether it be intumescent coating or foam left bare, this is what needs to make sure it's happening in that attic space. That attic space is to be used for the service of utilities only. No storage permitted. There is no storage allowed in that attic space. So this one can bite some people in the butt a couple times because technically there is a very, very obscure section of code that defines what attic storage is, and most people don't know where it is. I couldn't even tell you because I don't remember. But really what it comes down to is the building official subjectively determining whether or not the attic is intended for storage. I think it's quite obvious if you go into the attic and the entire floor has wood paneling laying on it, it's pretty obvious that that is intended for storage. But if you go up into an attic and there's wood paneling that kind of crosses the attic, getting you to any HVAC equipment, or maybe you're down south and there's water heaters up there, any sort of mechanical equipment, you know, it's subjective. Is that wood intended for storage or not? Typically, most building officials will say that wood is intended to access the mechanicals. It's not intended for storage. You're okay to go. But the point I want to make is that it kind of depends on the building official. There are no interconnected attic, crawl space, basement areas. In other words, the attic is not winding long and you know, squeezes down real tiny and then opens up real big again. It wants to have just a nice open space. Air in the attic or crawl space is not circulated to other parts of the building. This is also up to interpretation. It is Isoline Lapola's interpretation that a supply register in the attic is not circulating air to other parts of the building, but a return in the attic would be circulating air to other parts of the building. So adding a supply from the HVAC unit into the attic space is not taking that air and circulating it to other parts of the building. Whereas if you had a return where you're sucking air out of the attic, putting it into the HVAC system, then you are circulating air to other parts of the building. So that's important to consider. Combustion air is provided in accordance with the mechanical code. So if you have a mechanical equipment that requires air, it's not self-sealed, you may have to build a room around it in order to provide it the fresh air. Attic ventilation is provided where required, similar to that mechanical equipment. And underfloor crawl space ventilation is provided where required, again, for crawl spaces. But these restrictions don't really play much of a role in what we see. So at that point, we are done with the presentation for today, and we've got just over 10 minutes left inside of our time. And so I don't see any questions here that anyone has typed. So if you still have questions, please feel free. Now's the chance to type them in the chat box, and we can see if we can get those answered. Hopefully everyone finds the presentation that we gave useful in the ability to help discuss our end-use configuration testing. And like I mentioned, the follow-up email with the recording of the presentation will include the PDF of that trifold document for your use. While we're here, John, do you have anything to add to the conversation before we close it out?
Jay, the only thing I'd mention is if people do think of questions at any point, just email us, call us, and we'll respond. So you don't have to feel that they have to make questions right now.
Good point. Okay, well, I don't see any coming in. So I think with that, we will conclude the presentation. And I appreciate everyone for joining and giving us your time. Hopefully you found this useful. Feel free to give us feedback, and we will talk to you guys soon. Thank you for joining. Have a good day.